Welcome to the video on drawing resonance structures. Now I want to be clear. The word is pronounced resonance structures, not Renaissance structures. Renaissance structures are castles that kings and princesses live in. Okay? Resonance structures are when you have more than one correct way to draw a molecule. How do you know if there's going to be more than one correct way to draw a molecule? That means you've made a choice in your drawing of the molecule, and therefore you could have just as easily made the opposite choice. Some molecules you have no choice. This is just the way they are. For example, if we're going to draw one of the ones we did last class, H2S, there's only one correct way to do that. It's got to be H with the 4 electrons on the S, and then the other H over here. There's only one correct answer for that. But other molecules, for example, dinitrogen trioxide, can have more than one correct way to draw them. Let me demonstrate. Again, formula for this, 2 nitrogens, 3 oxygens. So we're going to put our nitrogens in the middle because they have fewer valence electrons than the oxygens. We put the oxygens on the outside. I did this example in class. Nitrogen, has 5 valence electrons, and there are 2 of them. Oxygen has 6 valence electrons, and there are 3 of them. For 28. Make our bonds. So then we subtract for each bond. So we have 20 left. And according to our count, we need 6 here, 2 here, 6 here, 4 here, 6 there. So that's a total of 24. And we only have 20, which tells us we need a double bond. Now, because all of these atoms are on the monster, we can put a double bond anywhere. Therefore, we have to make a choice. Where are we going to put this double bond? And I will choose to put it there. As soon as I do that, I've made a resonance structure because I could have just as easily chosen to put it here or here. I'll show you when I finish. All right, we're going to subtract 2 more for our bond. Now we need 4 here, none there. But that's a total, that's a total of 20. And I only have 18. So now I have to make another double bond. Now my choices are limited. I can't put another bond on this nitrogen because it's already full. So I can't put it here or here, so I have to put it here. So that one wasn't a choice. I'm left with 16, and now this goes down to 4, and this goes down to 2, and that's 16. So now we're done, and we put our valence electrons on. 6 here, 4 here, 2 here, and 4 there. Okay, now, like I said, I made a choice. I could have just as easily drawn this with the oxygen here, and here, and here. I could have put the double bond on this oxygen, and then that oxygen. So since I made a choice, I could have just easily made another choice. Or I could have chosen to put the double bond between the nitrogens, and then for that oxygen, and this oxygen. And so this would have the 6 valence electrons here, and 6 there, and there wouldn't be any valence electrons on my nitrogens. Sorry, I forgot to put the valence electrons for these guys. Okay? In all of these structures, I have 2 single bonds, 2 double bonds, and 8 lone pairs left over. It just depends on who gets the double bonds and who gets the lone pairs. So because all 3 of these would have been equally correct ways to draw this molecule, we call these resonance structures, and to indicate that these are resonance structures, we do a double-headed arrow between all 3 of these pictures. And if you were to look in nature at dinitrogen trioxide and ask yourself, what does this look like in nature? It would look like a mixture of all 3. The actual atom, the actual molecule would be somewhere in between this. So it's like this would be a double bond here, because it's always a double bond. But these other 3 bonds would be kind of like, not exactly double bonds and not exactly single bonds, they'd be sort of bond and a half. But we really can't draw 1.5 bonds. So we draw a double bond and a single bond and say it goes somewhere between. Now, how many resonance structures you had depends on how many choices you had available. In this case, we had 3 choices available. Sometimes you have 2 choices available. Sometimes there are 4 choices available. It depends on what is actually part of this molecule. But sometimes you don't even have any choices, and therefore you don't have resonance structures. Thank you.